Hello and welcome to this presentation about application performance monitoring with Elastic APM and the ELK Stack. Please don't forget to join slido.com with DevOps Pro code in order to be able to ask questions there. Okay, in this talk I will be speaking about these following points. First, I will tell you about my motivation for doing this talk. Then I will introduce the ELK Stack. And then after that, we'll see how to set up the ELK Stack. And after that, I will introduce Elastic APM. And then we'll see how to set up Elastic APM. And finally, we'll see how to monitor Spring Boot apps with Elastic APM. Okay, regarding the motivation, I couldn't help but notice the increased complexity of software development nowadays. Of course, I'm not speaking about a software development that one loner will build in his own corner with a few friends, in a garage of his parents, something like that. No, I'm speaking about enterprise application development that has become so complex in today's software industry. And of course, we start with a team, but we need also to define the methodology that we'll be using, whether we are building the software using agile methodology, waterfall, or whichever other methodology exists. And then we'll have to consider which type of solution architecture or application architecture to use. And that will lead, of course, to choices of frameworks and development technologies. And then we'll have to consider the application servers we'll be using for our middleware component and our business layer components and how they interact with each other. We'll also have to consider how to integrate with external services, maybe cloud services, software as service, business process as service, etc. There are so many cases for that. And then we'll have to consider build tools that we'll be using, for example, Maven, SBT, or also in the continuous development and integration pipeline, Jenkins. Then which versioning system we'll be using, Subversion, CVS, Git, and which qualimetry tools we'll be using, things like Sonar, PMD, Find Bugs, Cobertura, and many more. And then after that, we'll have to consider virtualization, orchestration, and containerization. Here we're speaking about things like VMware, virtual server, Kubernetes, OpenShift, and Docker. And after all that, we'll have to build different environment that will match the different life cycle of our software development. And we'll have, for example, a development environment, a commit environment, an acceptance environment, a pre-production environment, and a production environment. And then we'll have also to consider which programming language we'll be using on the backend side as well as on the frontend side. There will be different languages, for example, Java on the backend side, and on the frontend side, JavaScript and HTML, and we'll build on top of it with Angular or React or Vue.js, for example. And finally, we'll have to pick up a good IDE that will boost our productivity. And of course, for that, we have today good choices like Eclipse or IntelliJ platform. But that tells us about the complexity that we have today for that. And of course, once we have done all that, we need to consider the physical deployment infrastructure. And here we talk about things like security, reliability, scalability, distribution. And of course, our application will be accessed through internet or the cloud. So we'll have to go through firewalls, DNS routers, switches, and so on. And the different middleware we'll be using will be deployed on different physical infrastructure for the servers, and we'll have to communicate with each other in a complex pattern. So this leads me to ask myself some question. How can we ensure today that we are delivering the features at the level of requirements agreed upon with our customer? And when we notice that we are not getting this level of requirements, how do we fix it? How do we watch over the performances of our application in order to anticipate and quickly react to potential performances degradation? And so in this talk, we will see whether Elastic APM could come to the rescue. Elastic APM, as we'll see, is a new component that was recently released in the Elastic ecosystem, and we'll see how to make some application performance monitoring using Elastic APM. But before going to Elastic APM, we need first to introduce the ELK Stack, because Elastic APM is built upon the ELK Stack. The ELK Stack is named, this acrostic is defined because of the three main components that we have in the ELK Stack, which are the Elasticsearch server, the Logstash component, and the Kibana component. First, let's talk about the Elasticsearch server. Elasticsearch server is an open source search server that's based on the Apache Lucene server. It's a cross-platform because it's built in Java, so it's write once, run everywhere. And it's designed from origin to be scalable and to be distributed. It's also data source agnostic. That means it can connect to any data source, and we can be able to search through it. So let's talk now about the role of Elasticsearch in the ELK Stack. Elasticsearch plays a central role in the ELK Stack in the sense that the two other components need to connect to Elasticsearch to work properly. First, the Logstash component, which is in charge of gathering the data, will then ship these data to a stash, and in this case, Elasticsearch server. And on the other hand, the user interface component, Kibana, will read the data from the Elasticsearch cluster where they are stored. Other interesting features of the Elasticsearch server is that it's a real-time analytics server. That means that as soon as the data are stored in the Elastic cluster, they can be used. It's a full-text search server. It's document-oriented, and it's shipped with a very interesting RESTful API. The next component is the Logstash component. So Logstash is the component in the ELK Stack that is in charge of collecting the data from the various sources, gathering them together, transforming these data, and then ship them to the stash server, which is Elasticsearch server, for the purpose of analysis, archiving, research, monitoring, and alerting. And the third component is Kibana, which is the visual part of the ELK Stack. Kibana reads data from the Elasticsearch cluster, and with Kibana, we are able to produce meaningful representation of this data through reports and through dashboards that allows us to perform good interpretations of these data, and so that we can take right decisions about these data. To wrap up this structure with the three components we can see here, we can see an enterprise application, and we can see how the application, the business tier can ship the data through the Elastic Stack, going first through Logstash, and then Logstash ships the data to the Elasticsearch server, and finally the Kibana component can read the data from there to generate the dashboard that we'll use to visualize the results. All right, then let's see now how to set up the Elastic Stack, and that is something that can be done very easily. That's one of the interesting features of this platform. So I will start by launching an Elasticsearch server, and then I will launch the Logstash server and the Kibana, the Logstash instance and the Kibana instance as well. Of course, for the Logstash instance and Kibana instance to work correctly, I need to make some configuration so that they can connect to the Elasticsearch server. But let's start first with the Elasticsearch server. So I will connect to my Elasticsearch home, and I will launch the Elastic command, and that will launch an instance of the Elasticsearch server. So there's a lot of logs information that are showing up, but what we are really interested in this step is at what port the Elasticsearch server is being bound. And we can see in these logs that the server is being bound to the port 9200. So we can do something also to simply test that it's working as expected. Okay, something is not working right, but I will simply all right, I will start it again. I had to stop it because something did not work right. And while it's starting again, I will go and open a second terminal. First, we can check that it's working fine by sending, for example, a curl instruction to the address to which the Elasticsearch server is bound. So in this case, we are in localhost, and the port is 9200. So now we have an answer. The server has responded positively, so the server is up and running. The second thing that we can do is we will go to launch the Logstash server. And similarly, I will simply go to my Logstash home. And then here I wrote a small script that launches the Logstash instance with the -f flag here to give it a basic configuration file. What we do in this configuration file is simply that we specify which Elasticsearch server to use for this Logstash. The Logstash takes a little while to start. In the meantime, I can go and launch the Kibana instance. With a similar approach, I'll go to my Kibana home and I will launch Kibana. All right, the Logstash is responding. And we can see that it's bound on port 9600. In similar way, I can go to this terminal and write a curl instruction to ensure that the server is responding correctly. Yeah, it's responding correctly. Okay. The last component is Kibana. Kibana is also up and running. For Kibana, it's simpler to see it directly in the browser. We could see also the two others in the browser, but with Kibana, it's better visualized directly in the browser. So I'll go in my browser and run localhost. Kibana is running on port 5601. And so it seems that Kibana is also up and running correctly. So yeah, that's the visualization interface. We can see a rich menu on the left. What could be interesting for us right now directly to see, for example, what kind of dashboard we can build with Kibana. And to do that, I have some demos dashboard that I have loaded. And this is about some data for flight information, flight data. I really like this first donut report here. It's a little bit funny. We have some shares for an airline carrier shares from Kibana Airlines, JetBits Airlines, Elasticsearch Airlines, and Logstash Airlines. Okay, and that's apparently the one that has most part is the Logstash Airways share. But you can see that we can render all kind of reports, all kind of generated diagrams, and that makes it really interesting as a platform. We could also see how we could query the Elasticsearch server. As we have said, it offers us a very interesting RESTful API. So I will go here and access the RESTful API using a plugin that's called Sense. This plugin is a plugin that allows us to query the Elasticsearch server. So here we have the server that we have started, listening on port 9200, and you can see the queries as some JSON-based queries where we specify the HTTP verb to use, which query we are sending to the server, and some details about the queries. For example, this query will simply, with the criteria match all, will simply return all the data that are in our instance. I would not want to do that right now because I don't want my servers, the data to overload. But I could, for example, use this query. It's a post here. We are posting to an index that we call talks and a type that's called DevOps. So think about these index as databases and the types as table in the database, and the data that we have here as JSON data as row in a table, just to make a comparison with relational database that are more familiar to us. And so if I click on this button on the right to play this query, we have a response from the server, and the server has affected an ID to the data. That means that the data have been successfully created. And then we can, after that, think of, for example, making some queries on these data. Here I have a talk called Application Monitoring with Prometheus and Grafana. If I come to make here a query to search through this through the server for anything that matches Prometheus, for example, and I run this query, I have some results here that tells me that I have many hits for this query. I have a total of 5 hits for the query, so I have five rows that matches this Prometheus query. So this is a simple illustration of how we could query the Elasticsearch server with his API. And these are the queries just we have just seen, these 2 queries. For Logstash, for example, we have a similar configuration in Logstash, and Logstash allows us to define some pipelines where we define what are the input stream for Logstash and what are the output stream. In this demonstration, I'm using standard in as the input stream and 2 output streams that are Elasticsearch and standard out. That means that I can input some data to Logstash through the console, and then these data will be shipped to Elasticsearch, and they will be also shipped in the console as output data. Let's, for example, come here and say that I would send anything. Let's say, for example, hello DevOps Pro. As we are using standard in, the response is coming out also on standard out, and we should also normally be able to see directly in the Elasticsearch response from Kibana. Sorry, from Logstash, that Logstash data are coming. Okay, it seems to be a little bit slow down, but it should show up here also. All right. Similarly, the configuration for Kibana is very simple. To connect it to the server, it's done here in the Kibana YAML file, and all we need to do is to define a property called Elasticsearch host and give it a list of hosts the Kibana instance will be connecting to. All right, then after that, we will be now introducing Elastic APM. Elastic APM is an application performance monitoring component that's built on the top of Elastic Stack. It has been, the general availability was last February 2018, so it's relatively recent compared to the other component that exists in the Elastic Stack. It uses Elasticsearch as its data store. It uses log stash to collect, parse, and transforms the log data, and it uses Kibana to render and visualize all types of matrix-related dashboards. So what we can do with that is we can monitor with an instance of the Elastic APM servers. We can monitor, for example, thousands of applications. All our applications can be monitored with one instance of the Elasticsearch server. We can use it to automatically gather performance-relevant informations. And actually, the way it functions is that it will automatically instrumentalize our apps and allow us to measure response times for the requests. And how does Elastic APM fits into the Elastic ecosystem? It's quite simple. Elastic APM comes with two major components. One is the APM server, and the other is the APM agents. So the APM agent is the hook component that's hooked into our application and listen to lifecycle events of our application in order to collect relevant metrics information that will be then shipped to the APM server. And then the APM server will be able to generate some Elastic documents with that and send them to the Elasticsearch server. From the moment this information gets into the Elasticsearch server, it's now a matter of using the potential of the ELK stack. All right. Let's see here how to set up and run the Elastic APM server. That's also very simple, similar to what we have done with the other component. So I simply need to go to my Elastic APM home. And then here also I have a launch script that I wrote. As you can see, the launch script is simply running the APM server command with the flag. And if I launch this script, the APM server is running, and it's listening on port, by default on port 8200. The same way we can also check that it's up and running with curl command that says get to HTTP 8200. So it's answering. It's like a health check command. It's answering with awk, so it's up and running also. So the configuration of the the APM server to connect to the Elasticsearch server is as simple as the others. Also, we do it in a YAML file, and we specify which host to connect to. And so this is the URL for our Elasticsearch server listening on port 9200. Now let's talk a little bit about the internals of the Elastic APM. How does it work internally? What's the mechanism that makes it work? What's taking place here in the Elasticsearch APM server is the agents are the component that will be hooked up with our application to collect the performance metrics and the errors information. What do we mean by that? That these agents are actually libraries that are written in the same language as our application. And when we run our application at the same moment, at the runtime, we inject the agent in our application so that the agent can listen to event life cycles of our application and take this opportunity to collect relevant and meaningful data and send them to the APM server. So for example, if my application is a Java Enterprise application, then the agent that I'll be using will be an agent that is written in Java. If my application is maybe running under the .NET framework, it will be written in C# or F# or VB.NET, and so on. So all the collected data will be sent to the APM server, and the APM server will create the document and send the information to the Elasticsearch server, and the Elasticsearch server will store them in the Elastic cluster. The second part, the APM server, is an application that is written in the Go language. It runs like the other component as the Elasticsearch server, and as you have seen, it's listening by default on port 8200. Of course, these default configuration parameters can all be modified. They all exist in YAML files, YAML configuration files for the various components, so we can modify them at will. It also allows us to query it with RESTful API. All right, then. Now, what's taking place in the APM server is as the agent sends its informations, these data are received periodically, and they are used to build documents from the data collected. And these documents will be stored in the Elasticsearch cluster. With Kibana, then we can visualize the collected data, we can create dashboard, we can detect anomalies, we can create alerts in order to monitor and to manage our application. And we can go further, actually, when we are facing error cases, we can drill down into the transaction traces to see which methods were being executed so that we can pinpoint exactly in our code source the origins of the problems. All right, let's see how we can monitor Spring Boot applications with Elastic APM server in a demonstration also. So as I said, what we need to do is to inject the agent in our application at runtime. So for that, I will go and run a Spring Boot application with the agents. I will use a classic application, which is the Spring Pet Clinic. It's very well known. It's used for demonstration purposes. Okay, so I have a Talkstore home here, and I have a Spring Boot Pet Clinic application. So in the same way here, I have written a little launch script, and I just want to share what's being done in this launch script. So as you can see here, I'm using Java -jar, and my target application that I want to run, which is the classic approach to run a Java jar. And then here I have the flag -java agent, and to this flag I give the value that's here, which is actually the path to my Elastic APM agent here. And then I have a few other parameters that could be useful. For example, the Elastic APM service name, which is a name that you will give your the service under monitoring, in order that when you go to the Kibana user interface, you can easily visualize which service it is. So here I call it Pet Clinic. That's meaningful because the application is a Spring Pet Clinic. The second parameter, Elastic APM server URL, it's the URL of our APM server. So our APM server that we launched locally is listening on port 8200, and when we need some confidentiality, security, we can set up a token, a secret token, but here we don't need it. And the next parameter, Elastic APM application package, is a root package that I will use from where the Elastic agent will be listening to the lifecycle events. So this is the root package of the Pet Clinic application when we look at the source code. So here I just use a star jar to run the Pet Clinic jar that's behind. So let's run this script. As you can see, the first instructions are about the agent, checking that the server is up and running, it can connect to the server. And once that is done, the instructions that are coming next are the normal process of launching the Spring Boot application. So now the application is running and it's listening on port 8080. Let's go to this to the application just to generate a little bit of traffic so that we can have some data to feed to our APM server. So that's the Spring Pet Clinic application. That's just a demonstration application. There's not so much things there. We have a list of owners, some veterinarians. We have a menu where we can generate error cases. Let me come here to the list of owner and let me add an owner. And let's say, for example, test owner. And let's give it an address and say it's the multi-kino cinema. Yeah. And we are in Vilnius. And the telephone here is just a 10 digits number. All right, if I make a mistake, that's not very bad. All I need to do is to correct the mistake here. It tells me it's a 10-digit number. Yeah. So this is created, and then I will add some pets to this new owner. Let me say, for example, Tom, and Tom is born in 1940 on the 10th of February. Quite older than we think. It's a cat. I'll also add Jerry. He's born the same day. Jerry is a mouse, but unfortunately I don't have a mouse in the default list, so I will use hamster. That's closer to a mouse than something else. So we have 2 pets with this owner. Let's go to the list of veterinarians. We can also see the list of owners when we click on find owner without specifying any choices. And I could come here and edit an existing owner and change something in the address. Maybe he moved to a different place, for example. And then I will generate an error case here at the end of this instruction. This is meant for us to be able to see what type of issues an error case in a web application can provide. So now that I have done this, I can go to my Kibana and see. We can notice here we have an APM menu, and now you can see a list of services that are being under monitoring in my in this APM server. So by clicking on Pet Clinic, that's what we just defined. I can come here and see all kind of metrics related to that, the transaction durations, requests per minute, and I can see also a list of detailed queries to different endpoints, and I can go down in the details, see similar details, but just for the specific query that I've chosen, and I can go through the trace as well. I can see errors, and in this case we see the error that we purposefully generated to have an error case in the application. So here we have the details of what happened in the error. We even have some precise code source line where the problem happened, so we can really drill down inside and see exactly where the problem happened in order to try to fix the problem. So that was the demo for this, and just a few more points, but this we already seen in the demo, that we can access information about web requests, background jobs, errors, more statistic related information such as the 95th percentile, the 99th percentile, number of requests per minute. And of course, the interesting thing for us is that we will be able to analyze any performance issue through the errors, through the code, and go deeply in the code and see exactly where the problems are happening, because it allows us actually to zoom in and to pinpoint precisely where the problem is happening. The last part I want to speak about quickly is about notifications and alert. That's something very useful that we can do also with Elastic APM. It's not new with Elastic APM. It was already part of the Elasticsearch ecosystem, but it's enhanced with Elastic APM. So it's a way to periodically inform us when any metric exceeds some threshold values, then a notification is triggered, an alert can be generated, and we can react very quickly and try to solve the problem. It was done with two plugins, Watcher plugin and the XPack plugin, and now the XPack plugin has been directly integrated in Elasticsearch since version 6.6, and now we don't need to separately install the XPack plugin in order to be able to use that. So I put here a link in order to see the details about that. And wrapping up, we have seen in this presentation that software development and software development lifecycle has grown complex over time, and it makes monitoring difficult, but we can properly monitor our applications with Elastic APM because Elastic APM makes it really simple and beautiful. And also because Elastic APM is built on the ELK Stack that has been around for a long time, has proven itself very stable and very good. It's a very successful search ecosystem and platform. It provides us with a powerful and flexible search server. It's data source agnostic. We can really connect it to any type of data source. And we have a data gathering pipeline through the Logstash that allows us to gathers the data. And we have also seen that we have really very interesting, I would say, fantastic report and dashboard generation capabilities with Kibana. All right, in order to go further, you can go through these resources in order to go further in the different aspects that we have seen. The first link is about Elastic APM, the reference Elastic APM from Elastic website. It's really very complete and very interesting. The second part is about a better understanding of the search API. When we understand the search API, we can really do anything with the Elastic ecosystem because it's relied completely on that search API. And the third part is about going further with monitoring and alerting in Elastic ecosystem. That's a webinar also from Elastic company. Any question? I would like also to remind you that you can go to the slido.com with this code in order